good. Recommendations, get the fastest CPUs you can afford, not the most, right? The vendor is going to try to sell you 32 cores. No, get the fast ones, not the many cores, all right? And watch out for NUMA. Again, you should be using one CPU, right? And only the cores on one CPU. If you're virtualized on VMware, use the affinity. So in ESXi, there's a screen when you're configuring your VMs, and you can set CPU affinity. So you can basically say, this VM, I only want it to run on node 0 or node 1, right? And it does limit the ability, obviously, of VMware to like move you around and share resources in their scheduling, but you simply cannot run your machine with cores on multiple CPUs, multiple nodes, right? That will kill you. So make sure you enable CPU, no NUMA affinity in VMware when you're assigning your, when you're configuring your virtual machines. And what that means is you cannot assign more cores to a machine than you have cores per CPU. So if you have an 8-core per CPU box, then you cannot give more than 8 cores to your virtual machine. Now, the good news is anytime I go to a customer that has 16 or 24 cores, 99.9% of the time they don't need that, right? Someone just said it's slow, give them another 12 cores and see what happens, right? And usually it makes it worse, not better, when they do that. So make sure you only assign so many cores as you have, maximum up to the number of cores per CPU, and make sure that you set the affinity so that all the cores that you assign to that virtual machine are running on one physical CPU. Super, super important, right? And in my benchmarking presentation that I did last year, we ran a benchmark. I should have kept the slide. We ran a benchmark, and so we were running 8 cores. So this was a 4 CPU machine, 8 cores per CPU. So we ran the benchmark with the 8 cores on one CPU, and we were doing 4 million reads per second. That's the best I could pull out of the database, right? Tweaking it, doing all my magic DBA tricks, I could do 4 million reads per second using all 8 CPUs on the core. When I added one process on another core, right? One process on another core, my aggregate reads per second dropped to 3 million reads per second. I added one user on a different CPU. And when I added a second user on a different CPU, I dropped to 2 million reads per second. So essentially, my performance was cut in half by adding 2 processes that were running on a core that was on a different CPU. And that's the crux of the NUMA issue. So really, really important. Only use one CPU, only use the cores on one CPU, and only use the memory that is in that same node with that one CPU. Have I said it enough times? All right. But watch out for vCPU counts, right? So ESXi will create one vCPU per hyperthread, which is twice the number of cores. So you do have to watch out for that. But if the machine is not being scheduled, it can use up to that many cores nonetheless. All right, so watch out for that. All right, RAM. Most of you are not using the RAM in your machine. There's still this misconception about RAM usage. You look in whatever your favorite tool is, you see that it's 100% memory usage, and you think you're running out of RAM. It's not. The operating system will take any RAM that you're not using it, and it'll assign it to file system cache. All right. So in Linux, you want to look at mem available. In AIX, you want to look at num_perm percentage. That's the number you want to look at. So num_perm percentage or mem available. Take 10% of RAM, which you should reserve for file system cache. Anything more in num_perm percent in AIX is free memory. Anything more in mem available is free memory. All right. It means you're just not using it. And people think when we say using it, we should give it to the database -B, but no, most of you under-allocate RAM to client processes. And so these app server processes or batch processes, they're swapping to disk, they're doing temp table I/O, to disk. They're doing R code swapping to disk because you were stingy with the memory allocation to the clients. So if you've got 64 gigs and you're only using 8, well, give 16 gigs to the users or to the batch or to the app servers or PaaS or whatever. Give them the RAM. They'll be able to use it effectively. Cool. And disks, I won't hash the whole RAID 5 arguments, of course. The biggest thing I get today is, well, our SAN is all flash, so of course it's fast. And my counter argument to that is, it's fast, but it's in 3 kilometers away of fiber to get to that SAN. So there's always going to be a latency to go all the way there. And not only that, you go through a NIC, you go through a Brocade switch, you go through another layer, right? A SAN is actually just a big computer, and all of those steps introduce latency. So when we benchmark all flash SANs, they're still not fast. And for 99% of you, that's fine. It's more than good enough. It's not a problem. For 1% of you, that's going to be a problem, and you have to bring the disks closer to the server. That's more complicated. It's more expensive, but if your disk I/O requires it, well, then your disk I/O requires it. All right? And for the people who go to the cloud, I talk about it later, but there's this concept of ephemeral disks. There's pros and cons to that, but those are the fastest disks you can use if you go into Azure or AWS in the cloud. Good. An operating system, just go to the latest version that's supported. All right. I get the question too. Oh, we want to stay. We're on OpenEdge 10.2b, but we want to install on Windows 2022, whatever. I don't know. You're like, it's not supported. Will it work? I don't care. It's not supported. Like, it means that if your business has a problem 3 months from now, you're not going to get support, right? They're not going to fix this problem for you. So run on the latest version of the operating system that's supported. And when it comes to Linux, run on Red Hat. Does it run well on SUSE and Ubuntu? Probably, but Progress develops on Red Hat, and 99% of the Progress community runs on Red Hat. So you can either go against the tide or you can go with the tide, but you'll probably get better service, faster bug fixes, and less bugs if you use the same operating system that everybody else is using, which is Red Hat. And if you go, did anybody say they were on AWS already? Or anybody going to AWS? No one? So it's the same thing in Azure or AWS. Every couple of years, they come out with a new generation of servers. They call them R3, R4, R5, A3, A4, A5, and so on, and M3, M4, M5. The new generation is typically a faster server with more resources, more bandwidth, and usually at the same or a lower price. So you are definitely worth it for you to always go to the latest generation that's offered by AWS. You get faster for cheaper. And the only gotcha here is you might have signed up for some kind of savings plan or subscription or something to lower your costs. And you have to make sure that if you did that, that you can still take advantage of those costs on the new type of machine, or wait until your subscription finishes and on renewal, upgrade to the new machine type and then do a 1-year subscription on the new machine type, for example. But, you'll get instant 20% performance boost just by going stop, instance type R5.small or R5.large to R6.large, start, same price, 20% performance boost. And you didn't have to do any kind of hardware change. You didn't have to do any kind of physical hardware migration, no racking and unracking of servers. All you did was right-click stop, right-click change the type, right-click start. I'm doing okay on time. And then RAM versus CPU, you'll find in the cloud again that you can't say I want a machine with 11 CPUs and 42.7 gigs of RAM. You get machine types, and this type has these types of CPUs, this many CPUs, and this RAM. So you kind of pick from the menu the combinations that are available, and AWS makes available to you, I/O optimized, CPU optimized, memory optimized, depending on what you need, right? And most people just need what they call general purpose machines, which are a good balance of fast CPUs and quite a bit of RAM. And for disks, yeah, you want GP3 disks. And on Azure, they're called premium or ultra performance disks. Those disks I find are more expensive on Azure than they are on AWS for the same performance. So from there, AWS is cheaper.